Hello everyone, welcome to Learn News. Today's topic is recursion in C programming. What we will learn today is what is recursion, why do we use it, how recursion works, types of recursion, examples of recursion, and what is the difference between tail recursion and the non-tail recursion, and also comparison between recursion versus iteration, some common mistakes that we need to avoid, and the best practices that we need to follow, and at the end summary and best practices for using recursion efficiently. So let's jump right in. What is recursion? When a function calls itself to solve a problem is known as recursion. So instead of using loops, recursion allows us to break a problem into smaller parts until a base condition is met. So let's understand with a simple example. Here example problem is it is printing numbers from 1 to 5 using recursion. So here you can see the main function, and we have a function call with value 5 as an argument, and here we have a base condition, and then we are calling the same function again. This is the recursive call, and then we are printing after each recursion. So here output will be printed as 1, 2, 3, 4, 5, and some key takeaways are base case, which is nothing but the stopping condition is required as we saw here, and then the function calls itself with a modified argument. So here the value will be modified, and then it is calling the same function again. How recursion works: every recursive call creates a new function call on the stack. So when the base condition is met, calls start returning back, which means unwinding the stack. If no base condition exists, it will result into infinite recursion. So that will lead to stack overflow. What are the types of recursion? First one is direct recursion, which means function calls itself. Second one is indirect recursion, which means function calls another function, which calls the first function back. So let's understand with an example in the future slides. Direct recursion, here you can see we have a program which is printing numbers from 1 to n using direct recursion. Whatever the program code which we saw in the previous slide, here the same code is present. So here print numbers 5, 4, 3 and so on. So here it is like when we call with 5, value 5, it calls 4, and then which eventually calls 3. So like that, every time the argument will be reduced, and then when n becomes 0, the recursion stops. This is nothing but a base condition or a base case, and function starts returning, printing values in order from 1 to 5 like this. And some key takeaways are direct recursion is straightforward, and it is very easy to understand, and base condition is mandatory, mainly to prevent infinite recursion. Each function call is stored on the stack until it returns. So let's understand indirect recursion. So here what is happening is, from the main function we are calling function A. So it is going to function A, and from there we are calling function B. It is coming to function B, and then from there we are calling function A. So this is known as indirect recursion. Whatever I explained here, function A calls function B, and function B calls function A again. This is an example of indirect recursion. So let's go through some examples. First one is factorial using recursion. So this is the formula of factorial. Here is a code example. Here you can see we are using the formula to in the function. Here we are using the formula, so that will be returned. So the output of this code would be factorial of 5 would be 120. Similarly, another example would be Fibonacci series using recursion. So this is the formula, and this is the code. So based on the formula, we are calling the same function again and again, and then we are returning it back. So Fibonacci of 6 is 8, and main issue is This particular thing is inefficient for large n due to repeated calls, and also in order to avoid that, we can use dynamic programming or iterative approach. Now let's compare the difference between tail recursion and non-tail recursion. So tail recursion is, which means recursive call is the last operation in the function, but in case of non-tail recursion, function performs additional operations as well after completing that recursion. So here you can see in tail recursion, so this is the last operation. This is the recursive call and it is the last operation in this function. But when it comes to non-tail recursion, so this is the recursive call and this is not the last operation. After this it will be multiplied with n again. So that's why we call it as non-tail recursion. So tail recursion is optimized better by compilers for performance. So when to use recursion? When a problem can be broken into smaller subproblems like factorial trees, so in that case we can use recursion. When solving problems using divide and conquer approach we can use, and also for tree and graph traversal we can use mainly in the depth first search example. And then when not to use recursion? So when a problem can be solved iteratively with better performance, so in that case no need to go for recursion. And when memory efficiency is crucial, so in that case recursion is not recommended because it uses stack space. So what are the difference between recursion and iteration? So here with respect to code complexity, it is short, and iteration is longer but optimized. With respect to memory usage, recursion uses stack memory and iteration requires no extra memory. And performance, it is slower for larger inputs with respect to recursion, and iteration is faster and efficient. Best used for recursion is best used for problems with subproblems, whereas iteration is mainly used for simple loops, mainly for counting or searching. Let's go through some best examples, best practices and summary. So always define a base condition to stop recursion. Prefer tail recursion wherever possible for better optimization. If recursion is slow, consider iterative solutions. Don't go for recursion. These are some key takeaways. Recursion is when a function calls itself to solve smaller problems, and it is mainly useful for problems like factorial, tree, traversals. So these are some of the examples. And use recursion wisely to avoid inefficiency and stack overflow. Thank you for watching this video. Please like, share, subscribe to Learniverse for more such programming content. See you in the next video.